Sarah, are you online? If you are online, let me see your comment in the comment section. I'm online. I'm waiting for you. Still waiting for my students. Once you come online, then we can start. Let me know if you're online. Use the comment section. Tell me you're online. Sarah, are you with me? Kindly indicate your presence in the comment section. Sarah, is that you? Today we shall be looking at the laws of indices. At the last class, which was held yesterday, I introduced you to indices. So we shall be looking at the laws of indices in today's class. Let me know if you're online so that we can start the class. Sarah? Sarah, I'm waiting for you. Sarah, are you with me? Sarah, if you're online, kindly comment at the comment section. Let me know if I can start or still wait for you. Okay, Sarah is online, so I can kickstart the class. Good evening and welcome to today's class. I hope you had a great day, Sarah, and our friends online. Today's class is a continuation of our previous classes on indices for GSS2 mathematics. At the previous class, I introduced the house into the study of indices, where we said any number expressed in this form, a raised to the power of a, is said to be an index form, where a is said to be the base and n is said to be the power, exponential, or index. Now we shall be looking at the laws of indices. Before now, that was at the previous class, I showed you how to convert from ordinary numbers to indices using the expansion method. And we did so many exercises as to how to convert from ordinary numbers to index numbers and how to convert from index numbers back to ordinary numbers. Having known that, we shall look at the laws of indices in today's class. Now, what is the essence of expressing numbers in the index form? Remember in GSS2, GSS or GSS1, when you were introduced into larger numbers, we're told that numbers into millions and trillions are too difficult to handle in terms of multiplication and division, as well as you dividing smaller numbers. If you are to divide smaller numbers, it will also be too difficult for you to divide because they seem to be very small. So the only way for us, or the best way for us to do this, is to express them in standard forms. When you express numbers in standard forms, part of it is said to be in index form. So how do you simplify numbers in index form? Once you are able to simplify it express it in index form, then you should be able to maneuver it in terms of carrying out the mathematical operations under indices. And that is what we refer to as the laws of indices. So at today's topic, we will center on laws of indices. There are so many laws of indices. I shall take them one at a time in no particular order. So you may refer to a law in indices, a law of indices that you refer to as law number 1 may be expressed as somebody as law number 2. But all laws still mean the same thing, irrespective of who is involved. So we shall be looking at laws of indices in today's class. Sarah, I believe you can hear me. Sarah, can you hear me? Let me know if you can hear me. Okay, Sarah says she can hear me loud and clear. So we shall move now. Laws of indices. Now I said recall that a raised to the power of n means a multiplied by itself n times. So if a raised to the power of 5 is equal to a times 5 times 5 times 5 times 5, that is what we meant. That is, a is being multiplied by itself 5 times, and which in expanded form we say is equal to a times a times a times a times a. That was what we did at the last class yesterday. Now let us consider what happens when two numbers in index form let us consider what happens when two numbers in index form with same base are multiplied. So we have an example 1 that we should simplify a raised to the power of 4 times a raised to the power of 3. Now, how do you multiply this? A raised to the power of, this can be expressed as a raised to the power of 4 can be said to be equal to a times a times a times a, which is a raised to the power of 4. And we are asked to multiply it by a raised to the power of 3. So we multiply it by a times a times a. So therefore, this can be said to be equal to the a times a times a times a, when you remove the bracket, times a times a times a. And in index form, we say this is equal to the a raised to the power of 1, 2, 3, 4, 5, 6, 7. That is to be a raised to the power of 7. So that note that the power in the final answer, which is a raised to the power of 7, is equal to the addition of the powers of a raised to the power of 4 and a raised to the power of 3. So what I said in essence is that you observe that the power of the final answer, which is 7, is equal to the sum of a raised to the power of 4 and a raised to the power of 3, or is equal to the sum of the powers of the two index numbers. So a raised to the power of 4 times a raised to the power of 3 a raised to the power of 4 times a raised to the power of 3 is equals to a raised to the power of 4 plus 3, which is equals to a raised to the power of 7. Let's take another example. Example 2, we are asked to simplify y to power 3 times y to power 2. Do it the same way I did at the previous example. This is equal to bracket y times y times y to be multiplied by y times y. Remember, I told you that in expanded form, y raised to the power of 3 is said to be this, and y squared is said to be y times y. So when you have to multiply y raised to the power of 3 by y raised to the power of 2, this can be expressed now as y times y times y times y times y, which is equal to y to the power of 1, 2, 3, 4, 5 in index form. Same thing. Note also that the power in the final answer is equal to the addition of the powers of y raised to the power of 3 and y raised to the power of 2. So if you look at it, this is y raised to the power of 5, and it's said to be equal to when you add the powers of these two, meaning the base is constant and is equal to the sum of the two powers. So in general, when you have a to power m times a to power n, it can be said to be equal to the a raised to the power of n plus n, because we have done the multiplication of two indices together, and we have seen that the final answer is equal to the sum of the powers of the constituent indices. So in general, we can then conclude that a raised to the power of m times a raised to the power of n is equal to the a raised to the power of m plus n. Note that the bases are equal, while the powers are not. So it is only possible to add two indices, the powers of two indices together, when the bases are equal. But when they are not equal, you cannot just add them together. So this is called the indices law of addition. Furthermore, when the bases given are equal, you should add the powers. That's the indices. But the base remains the same. If they are algebraic expressions, multiply the coefficients. The base of the letters given remains the same, and the powers are added. Now, what we are saying in essence is this: when there are algebraic expressions, you are to multiply the coefficients, which are, for example, 4 and 5, and then you express others in terms of laws of indices. So we have an example for us to solve that we should simplify 4a raised to the power of 4 b cubed times 5a squared. Now, how do we multiply this? I have already said it at the literature text above. That when you have an expression, algebraic expression, or two algebraic terms being multiplied together, and you are asked to multiply using laws of indices because they are expressed in index form, you are to pick out the coefficient terms, multiply them together, and then multiply the letters using the laws of indices. Now, what do you mean, or what do I mean by coefficient? Coefficient of a term is said to be the number of that term. For example, 4 is said to be the coefficient of a raised to the power of 4, b raised to the power of 3. And 5 is said to be the coefficient of a squared. So, if I'm to express this, this will be equal to bracket 4 times 5, which are the coefficient terms, times, you now pick them according to their numbers, or according to like terms, which is 3 times a raised to the power of 4 times a raised to the power of 2 times b raised to the power of 3. There's no other b term in the second expression. So this can be simplified to be equal to 4 times 5 is 20 times a raised to the power of 4 times a raised to the power of 2. You can then apply the additional law of indices, which says when the bases are equal and you have to multiply the indices, you add the powers. So this is equal to be a raised to the power of 4 plus 2, then times b raised to the power of 3. This can be simplified further to be 20 times a raised to the power of 6, because 4 plus 2 is 6, times b raised to the power of 3. So that this is equal to be 20 a raised to the power of 6, b raised to the power of 3. So when you are asked to multiply these two terms, this is what you will get as your answer. Kindly like our videos as you watch, while I recommend that you subscribe to this channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You are also encouraged to use the comment section to interact with me on areas that are still difficult for you to understand. This live session occurs daily as from 7 p.m. to 9 p.m. on mathematics. So we shall take more examples on the additional laws of indices. Example 2. B. We are asked to multiply 2u squared b raised to the power of 5 times 3uv. So what do you do in this case? You do the same as what I have done. Multiply out the coefficient, that is 2 and 3. Then multiply them like terms by like terms, and you arrive at your answer. So this is equal to 2 times 3 times u squared times u times v raised to the power of 5 times v. Now when you multiply this, 2 times 3 is 6 times u squared times u. U means u raised to the power of 1, and as well as v. So this is v raised to the power of 1. When there is no coefficient attached to it in terms of powers, you know that that power is said to be 1. So u raised to the power of u squared times u raised to the power of 1 is said to be u raised to the power of 2 plus 1. Remember, this is the additional law of indices. Times, do same with v. This is v raised to the power of 5 plus 1. This is only possible when the bases are equal. So this is equal to 6 times u cubed times v raised to the power of 6, which is equal to 6 v u cubed v raised to the power of 6. So this is what you will get. Okay, let me take some questions from you now. Do you have any questions, Sarah? Sarah, do you understand? Do you have a question? Let me take questions from you. Okay, so it's clear to Sarah. Let's move ahead. I'm I'm going to give you exercises now to solve. Exercise 1.1 says you should evaluate the following by expanding the terms. By expanding the terms. Now you are not to apply the laws of indices, okay? You have to do that by expanding the terms. So I'm going to solve A for you, then you follow suit in solving number 2, 3, and others, okay? So evaluate the following by expanding the terms. So always follow the instructions by expanding the terms. For you to evaluate this can be said to be equal to a raised to the power of 5 can be expressed as a times a times a times a times a times a raised to the power of 3 is said to be a times a times a, so that this now becomes a times a times a times a times a. When you remove the bracket, times, then you recopy what you have in the second bracket, a times a times a, so that this is equal to a raised to the power of 8. So this is what you are asked to do. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So this is what you have to do. Follow the example I just did, and then you solve number 2, number 3, and others. So good luck. Follow these examples, and then you solve this. So do it right away. Let me see. Yes, if you are just joining us for today's class, you are welcome. Let me know where you are chatting from using the comment section. This is mathematics classes for those in JSS2. We are looking at indices. I have introduced indices at the previous classes. In today's class, we are looking at a lot of indices, and we're about solving exercises at the moment. If you understand what we have been doing, kindly go ahead to solve the exercises and then give me feedback in the comment section. Okay. Sarah, I'll request that you put it in expanded form. That's what the question is saying. I want to see your working, okay? I would like to see your working. Can you send your working to me? Work it out on your exercise book, and then you snap and send to me. Okay, just give me the answers without the working, Sarah. Let me have the answers without the working. Let me have the answers without the working. Number 2 is 2 to the power 12, correct? What about 3? Number 3 is 5 to the power 9. Yes. That's correct. Number 4, you said is n to the power 10. Yes, Sarah, that's correct. That's beautiful. So let's look at exercise 1.2. In exercise 1.2, You are asked to evaluate the following by adding the indices. Now the instructions have changed by adding the indices. So you are not to use the expanded form again, rather it's just to add the indices, so that this can be expressed as 3 raised to the power of 8 plus 12, which is equal to 3 raised to the power of 20. So this is what you're expected to do, Sarah. So go ahead and solve further questions. Okay, number 2, you said the answer is 15 to the power 5. Okay, that's correct. T to the power 25, correct. Number 4, k to the power 17, correct. Okay. Okay, for number 5, since they are not like terms, you can just leave it as 5 raised to the power of m plus n. Okay, you can only add them together when they are like terms, but since they are not like terms, then it becomes an expression. So let it be as 5 raised to the power of n plus n. Sarah, go ahead with your solution. I'll presume you mean 5 to the power of n plus n. That's 5 raised to the power of n plus n. Okay, then number 6 is 13 to the power x plus y. That's correct. That is correct. Let's take one more example or exercise. Now, in this exercise, you are having coefficients. Okay, so let me see you solve them. Let me do question 1 as an example for you to follow, or as a reminder. You have to multiply out the coefficients and then multiply them like terms by like terms, so that this becomes bracket 2 times 7 times bracket c cubed times c raised to the power 5. I had to multiply them like terms by like term. Constant term, I multiply them together, as well as those that have this C, I multiply them together. So that this gives me 14 times C raised to the power of, we then apply log indices when necessary. 3 plus 5, this is equal to 14C raised to the power of 8. So 7 is what you have to do. But since you are submitting your answers online, you can just give me the final answer, but let your working be there in your exercise book. So solve it in your exercise book and then copy out your final answer and send to me using the comment section. Same to with other students online. So let's go. So let me see something number 2. Sir, I'm still waiting. Send me your answers. Okay. She said it's 68 to the power 12. Let me see. That's correct, Sarah. But I would prefer you write it as 60 times a to the power 12. Because leaving it as 60a to the power 12 simply means the 60 is also raised to the power 12. So there's a difference between 60a to the power 12 and 60 times a to the power 12. Go ahead with the next question. Okay. Sarah said number 3 is 5 to the power of 3 times m. Okay, 5 to the power of 3 times m to the power 9. 5 to the power of 3, correct, times m to the power 9. Okay, correct. That's true. Next. Solution to 4. Number 4, 5 to the power 3 times 7 to the power 7. Yes, that's correct. That's correct. What about question 5? Petra, Sarah, I'm impressed. That shows you are actually following. Keep it up. For those of you still watching, if you know you're up to the task, you can also pick a pen and paper and start solving. At the end of the class, I'm going to give you the solutions to all this. So for now, this is mainly to be solved by students as classwork. If you are just joining us, we are having a class on indices where we are looking at the laws of indices. So we are looking at the first law, which is the additional law of indices. So we are now solving exercises, after which we shall look at the subtraction law. Sarah, I'm waiting for you. Number 5, you've got 450 times x to the power of 14. That's correct. That's correct. Number 5. So let's look at 6 to 10. Number 6. So 881 times p to the power of 15. That is wrong. Try and multiply again and see. Let me see if we can spot out your error. So right, when you multiply 8 times 10 times 11, I doubt if it will give you 881. So cross-check your answer. Others are correct, but the multiplication of the coefficient is wrong. Okay, you've corrected. That was number 6. Sarah, still waiting for solution to 789. Okay, 7, you said it's 77 times u to the power of 8 times v. Yes, that's correct. Number 8. Okay, you said number 8 is 192 times a to the power of 12. Number 8, let me see. Okay, that's correct. Number 9 and 10. Number 9, e to the power of 9x. Yes. And number 10. Sarah, waiting for your final answer. Okay, Sarah, for that of number 10, just apply the rules. There's nothing different, okay? Don't be discouraged by that expression you are seeing as the power of 5. Just apply the rules. I want you to try it. Sarah, have you been able to solve number 10? Can you attempt it? Or you want me to give you the solution? Okay, you say 25 to the power of 4b plus 2. Correct. That's good, okay? Sarah, that's nice. That's good. Okay, so Sarah, we are going to end the class at this point. We're going to end the class at this point, and we'll continue with laws of indices tomorrow, where we shall be looking at the subtraction law and other laws of indices. I want to appreciate your efforts. You have tremendously done well into this class, and I want you to keep it up. Okay? Keep it up. You seem to be improving, and I love that. Don't relent. After tomorrow's class, I'm going to give you more exercises to try on your own, and also for viewers who are following us. Don't forget to like this live as you watch, and also share the link with your friends and loved ones so that they can also join us in our evening classes as from 7 p.m. to 9 p.m. So thank you for having a great day with us. See you tomorrow. And don't forget to come with your questions, okay? So Sarah, have a nice day and see you tomorrow. See you Wednesday, sorry.